Okay, so I wanted to make this a little bit more personal than usual, and I haven't really made many videos in the past 2 months. I'm starting to put up more videos. I'm actually waiting for my computer to process one video and completing it. Uh, but this video is mainly going to be what I'm working on, things that are happening. I'm not going to tell you specifically what I'm working on. I will tell you what I'm working on during school and all this other stuff, projects I have going on at school. But my personal projects, I'm gonna leave up to the videos that I post about them during winter break, which is actually this coming up week. And I'll be off for 2 weeks from school, so I'll be able to do a bunch of stuff. One of the things that I've gotten into the past 6 months or so is Minecraft. A lot of you guys know Minecraft. I became about a super mod on two different servers, and those servers got shut down because due to insufficient funding for the servers themselves. One of them was the MinecraftForums.com server, not .net, and the other one was Edgecraft, and I was super mods on them. So that was one of the things. Um, I think I mentioned that in my last video too. Not the last video, but the one before that, the update, or I'm back, baby. But yeah, so I've been working on a bunch of stuff. I'm doing things in correlation with big companies. One of them, well, it's just one. One of the major companies is named Air Products. They make like different kinds of. They make all the types of gases and fuels for like different types of crafts, or well, vehicles. They make them for NASA. They make the fuel for NASA. They make kerosene for jets. They make, or they actually find gas in nature, and they refine all the gases, different types of gases, um, anywhere from hydrogen, helium, all the way to like argon and xenon and all this other stuff. And they're a multi-billion-dollar company. They do contracts with DARPA, NASA, Raytheon, Sarcos. They do a bunch of crap around the nation. And one of their main plants is here in Dallas, Texas. It's not in Dallas, Texas. It's in Fort Worth, I think. But it's in the DFW Metroplex. And they decided that they wanted to support last year's Skills USA contests. And this year they decided they wanted to be part of Duncanville High School's engineering program. So now they're funding many of the projects that we actually have. And they're funding two of my projects. One of them is the Over Unity Generator project, which is literally a generator that creates more electricity, not creates, because that's impossible. It puts out more electricity than you put in with magnets, because magnets would be a magnetic potential energy, and you could use that to bring out more energy than what you put in through the magnets and not just through the electrical systems themselves. So it's kind of hard to go into explanation. I will show my diagrams. I think in the coming videos. We haven't really started real construction, but we have done experiments with neodymium rare earth magnets. They're about 35-pound pull magnets. They're really strong. We've done experiments with those. We've also done a little bit of things with electromagnets and ferromagnetism and all this other stuff, and ferrofluids and a bunch of different other crap. And it's pretty cool so far. That is one of my projects. That project hasn't really got off the ground because we haven't gotten all of our parts in. And tomorrow, Air Products is coming to the high school, and I'm taking my camera to school, and I'm going to record some of the presentations, especially for one of my projects that my classmates are going to be doing. I'm going to record them, and I'm also going to edit pretty much, it's going to be an engineering Duncanville High School engineering video, and it's going to be all about the engineering stuff at the high school in Duncanville, Texas. And I'm going to be just recording everything. My other project, which is the one that my classmates are going to be presenting for me because they're going to competition for the project. I am not. I'm going for two other competitions, and I can't do more than two. So I already decided this before I even decided it was going to become a competition for them. And there's three people, and it's a three-person team for the competition, so it would work out. So because they want to go to competition as well. So it's for the engineering technology competition. It's practically a design project that you make up on your own, which we did. Well, actually, I did, and they've helped me so much so far. They're into the project and all this other crap. Why did I say all this other crap? I don't know, but they've helped so much, and they've actually gotten into it. They're starting to bring up their own ideas. But the project, just so I can tell you, I think I already told in another video before this, it's Project ESAR, Elevator Service Autonomous Repair Robot. It's ESARR. And I'm going to bring up a full video. I'm actually going to do a separate video tomorrow. I'm going to record that. I'm not going to really do much on the Over Unity generated project because we haven't really gotten anything. I might just show the magnets and that's it. But we're gonna what it is pretty much a robot that goes into an elevator shaft whenever there's a malfunction in the elevator in the car, or such as one of the cables is snapped or one of the cables is loose and now the car is rocking, or when the emergency light comes on in an elevator and it stops and you can't get out. What if the elevator's to a point where it can't let anybody out? You need something to go in there to see what's up, to try and fix the problem as quick as possible without any endangering of any type of any human. So pretty much the robot goes inside. It has its own autonomous programming, which allows it to go up and down the elevator shaft and spot any problems inside the elevator shaft. It has its own coding and software that we're going to code for the final competition. And it's going to be able to go inside the elevator shaft, and the code's going to tell it what's to look for, and to tell the engineer that's actually on one of the floors safely, tell him if something's wrong. If something's wrong, the engineer takes a remote control and a remote display and actually goes in for the robot and does everything manually. He takes the control and he's able to control a small robotic arm, and the robotic arm extends away from the robot and is able to reach about the prototype's only going to reach about a foot away from the robot, which is about the minimal distance of electrical panels that are inside of a elevator shaft that run all the electronics inside of it. So it's about a foot away, and it has 3 joints. It has an elbow joint, a wrist joint, and then it has the it has an elbow joint, a wrist joint, an elbow joint, a shoulder joint. I think that's all it is. And then it's able to turn a screw, and it's able to take off panels and put them back on. And it's actually, what it does is it attaches itself to a something called a guide rail inside of an elevator. It is what the elevator rides on while it's being pulled up by the winch, which is at the top of the service room that's at the top of the elevator shaft. And this robot does everything by itself, and you can see it through a remote display. You can take control on your own, and it's designed. The project is supposed to create a job and save a person's life. There has actually been, I've actually read and I've gone through research of people actually dying or getting killed or something like this or something like that when they're fixing stuff inside of an elevator shaft. So I did a little more research, and I found that about a couple thousand people per year die of elevator accidents. So per year, a couple thousand, that doesn't seem like a lot, but it's something that can be avoided. It's something that can be fixed, something that can be, or enhanced, not really fixed and not perfected, but can be enhanced. It can prevent more and more deaths whenever an elevator is being serviced, or whenever an elevator fails to operate the way it's supposed to. So I thought of a project that would create a robot that would do all this, and there's 3 different designs. One of them is just a service bot, or not really a service, it's just a service check bot. All it does, it has a camera system, it goes into the elevator shaft, picks out and finds everything that's wrong with it, and if there's anything wrong, then the engineer knows exactly where to go, so he doesn't need to waste any time going to the elevator shaft. The first model requires the engineer to go into the elevator shaft, but it prevents him from taking too much time and risking the elevator either the winches breaking and it falling on him, or prevent any more time being wasted if the cable or the line should snap what he's connected to. So that's the first robot. The second robot, the one that the main robot that we're designing, is one that does have the camera system, but also has the robotic arm, which can go into the elevator shaft and have a screwdriver and pretty much take off all the panels and look around and actually do repairs on its own. The third robot is not really a robot. It's actually a platform. This platform is actually is the conceptual designs that me and my team have thought of. is pretty much a platform that folds out from the wall inside the elevator shaft. What it does is it kind of transforms. It's already attached to the guide rails at the bottom of the elevator shaft. Whenever it's needed, it turns on and it unfolds itself out from the side of the wall. So whenever it's folded up, the elevator won't hit it. So that's why it needs to fold away from the wall to get back onto the rails. When it's back onto the rail, this platform is also a robot, but it's mainly a platform. It's able to go up and down the elevator shaft. It has a control joystick kind of thing that allows it to move up and down the elevator shaft. This thing actually covers the whole span of the elevator shaft and allows an engineer to stand on it with any type of tools he needs, especially welding equipment. He'll be able to stand on the platform. The platform has braking systems, it has drive systems, and its ability is to bring the engineer up and down the elevator shaft faster than the elevator can, and be more the engineer is still harnessed. He's still on a harness, so he won't fall even if the platform falls, if the platform fails. But the platform is supposed to keep the engineer from falling through the elevator shaft and possibly having something happen. So that's also that's the final design. There's 3 different robots. The final design, which is the platform, will not be produced by us because that thing is too dang big to even try and think of in our theater of operations. Why would I say theater of operations? I don't know. But it's not even really that possible. So, yeah. But that's pretty much it. That's all I wanted to talk about. I know this video has gone on a long time. 12 minutes almost. So, I'm going to get off before someone comes upstairs and interrupts the video, like being stupid. And I think my laptop's almost done doing that video. That video is, well, actually, that video will be up before this one, so don't even worry about it. But I'm bringing up more videos, and special update, the Iron Man suit, the K'NEX Iron Man Mark III Update 5 Finale, which is the final design of the suit. Well, it's not the final design, it's the final creation. It's pretty much going to be a statue. I'm not going to wear it due to the fact that the joints aren't really going to be able to work that well. So all I'm going to do is just going to stand it up, and that's pretty much it. Lock all the joints and make it stand in pretty much in one position or one pose, and it's going to be pointing out a repulsor probably. I'm not exactly sure. I haven't done with the gloves yet, and I haven't gotten the repulsors completely done yet. And that will be on Christmas Day. That video will come out, and I'll also be announcing my new projects on that day. And a lot of cool stuff is coming up this winter break, so be prepared. And that's pretty much it. Oh, god dang, 13 minutes. Oh my god. Okay, yeah, I gotta go. So, yeah, thanks everybody for watching. I don't know who's gonna watch this video because it's too dang long, but I don't know. Go ahead if you want to. But, thanks for watching. Leave a comment below about what you think about my new projects for school, where you think they're headed, and if you think you want to get on, actually join in on them. I'll actually take suggestions. I'll add you into documentation. If you want to send in any designs you think I should do, or anything like that, I'll add it into the documentation, and you will be a part of the projects, kind of. You will be noted for your contributions. So that's pretty much it. Now it's almost 14 minutes. I'm going to go because I'm going to reach my 15-minute time limit. So thanks for watching. See you guys later.